We're going to start 3-2 radians and degrees. So we are going to transform or convert angles from radians to degrees. So first of all, we need to talk about what a radian is. What a radian is actually the radius of the circle measured out on the circumference of the circle. So every circle has approximately 6.24 radian in it, which is 2 pi. And we've already talked about we have 0, pi, and then 2 pi. So every circle has approximately 2 pi radian in it. So how we find a radian, so to go from a degree measure to a radian measure, we have the conversion factor of 360 degrees. Sorry. We have a conversion factor of 2 pi is equivalent to 360 degrees. So that is pi over 180. So we would multiply the degree by pi over 180 to go from degrees to radians, and to go from radians to degrees, we would do 360 degrees divided by 2 pi, which is equivalent to 180 degrees over pi. Now, just so you have a picture in your minds, if I were to do 20 degrees, we'd be like right here is 20 degrees. But 20 radians is once, twice, oh, I gotta go another time. Is somewhere like right here. So you notice we have a degree symbol and a degree in radians. Typically what I say is if you don't have a degree symbol, my assumption is that you have it in radians. So make sure you're not forgetting your degree symbols. So convert 45 degrees to radians. So I said my conversion factor from degrees to radians is pi over 180. Now the easiest way to remember that is you take 45 degrees times pi over 180 degrees. Your units need to cross out. So that's kind of how I always remembered it when I was first starting, that the degrees were opposite because they're reducing out. So let's see, I bet, well, 9 goes in here 5, and 9 goes in here 20. I can still reduce it to 4. So 45 degrees is equal to pi over 4 radians. So I need to convert 450 degrees to radians. So again, I just take 450 times pi, degrees times pi over 180 degrees. So I'm going to reduce out a 0 and the degree at the same time. And 9 goes in here 5, in here 2. So 45, I can't even talk, 450 degrees is equal to 5 pi over 2 radians. So let's go from radians to degrees now. So convert radian to degrees. So I have pi over 6. So again, my conversion factor is 180 over pi for radians to degrees, because again, I'm going to want my pi to reduce out and a degree to come back into the answer. So times 180 degrees over pi. Pi's reduce. 6 goes into 8, 180 30 times. So pi over 6 is equal to 30 degrees. Okay, so we're going to convert 4 pi over 3 to degrees. So again, I'm just going to do my 180 degrees over pi. So I want my pi's to reduce out, my degree to come back in. 3 goes into 180. That would be 60. So I have 4 times 60. So 4 pi over 3 is equal to 240 degrees. The same conversion goes for negative angles. It just goes for about anything. They're going to have your exact value tables that you're going to be using. So keep working on those. Keep working on those flashcards. So they'll have find the sine of pi over 6. So the sine of pi over 6, well, this is one you know, because 6 goes 180 30 times. So it's going to be the sine, and this is just 1 pi over 6. So that leaves me right here at 30 degrees. And opposite 30 degrees is 1/2. Do not convert them on paper. If you need to convert them in your head for a while, that's one thing, but do not convert them on paper. Another kind of problem you'll have today, you have 4 sine of 7 pi over 6. Now, your book does not put parentheses, but parentheses are your friend. I am going to do some reference angle things with this. So I'm in my coordinate plane. I know that 180 is pi. 7 pi over 6 is one piece larger. So it's right here. So I know sine is negative in this quadrant. So I have 4 times negative the sine of, well, the sine for 7 of pi over 6, the reference angle is pi over 6 right here. So the sine of pi over 6. So that gives me 4. I'm going to put that negative, just bring that out, negative. And the sine of pi over 6, which is 30 degrees, is 1/2. So negative 4 times 1/2 is negative 2. So you'll be asked to use these in the same way as you've done with degrees before. Another problem you will be asked to do is this: evaluate. So you have find and evaluate. Those are words that mean just do it. So it says 4 sine of 2x plus pi when x equals pi over 6. Now again, the book writes that pi and that 6. They write it like this, which is absolutely horrible, so try not to do that. So x is pi over 6, so I just plug that in for the x. So 4 sine of 2 times x, which is pi over 6, plus pi. So 2 goes into 6 3 times. So I have 4 sine of pi over 3 plus pi. So I need to get my common denominator. So pi is going to be 3 pi over 3. So pi over 3 plus 3 pi over 3 is 4 pi over 3. So I need to evaluate the sine of 4 pi over 3. So it's 1 larger than pi, so I know it's over here. This is 4 pi over 3. My reference angle has a 3 in the denominator, so 180 divided by 3 gives you 60. So there's your reference angle, or pi over 3. Got to interchange those in your brain. So I need, 4. Well, the sine, sine's also negative over here in that third quadrant, so it's going to be negative. And then of 60, well, opposite of 60 is square root of 3 over 2. So 2 goes into 4 twice. So my answer then, I feel like I'm off the page, sorry, is negative 2 square root of 3. So just step through that process. I have one last example for you. Maybe not. Oh, yes. Well, I guess 2. So if I were to ask you to simplify and the expression, so simplify 2 pi minus pi over 3. So I just have to get common denominators. So this is over 1 now, so it needs to be over 3. So I just have to multiply this by 3. So that gives me 6 pi minus pi, which would be 5 pi over 3. So just remember the common denominators. And then it will ask you if I have 2 pi over 3 to give me two, like it says, give me a sum or difference involving pi. So I have to have pi in there, so I have to take this apart. So a sum would be like pi over 3 plus pi over 3. That'd be an easy way to get it. You could do a difference. Well, I have one piece less, right? So I could say pi minus pi over 3, which would give me 2 pi over 3. So you just have to get some common denominators and work with that kind of stuff to do those. I think that's it.